Okay, we have around 72. Okay, still people are coming in. Okay, so please don't come too late because all these names are unverified. So I need to add one by one. Okay, so as you are coming, it will disrupt the teaching and learning. Okay, so please cooperate and please join before 8:05. So we will begin our lecture at 8:05. Okay, so good morning again. Okay, so as today we will be entering chapter 4. The name is quite important subject chapters. Okay, so at chapter 4 and chapter 5, because here you will begin to design your own circuit. Okay, similar like how you have seen in your lab. Okay, so I still consider it very simple circuits. Okay, especially when controlling only one or two actuators. Okay, which we will see we have cylinder 1 and cylinder 2 maximum. But in industry, we will have many cylinders controlled by a system. Okay? So today particularly we will see chapter 4 focusing on single actuator circuit. Single actuator apa maksud dia? So what's the meaning of single actuator? Anyone? Single actuator. Anyone can try. Arman, nak try ke? Apa maksud single actuator? Don't know if anyone to try. Yeah.
One port piston with it.
Yes, only one piston. Okay, so today we will see in chapter 4 a circuit with only one piston. Ya, ataupun satu cylinder. Okay, so that is what we call as single actuator circuit. Okay, so in order to control that single actuator, so you need to have your circuit. Kalau ada circuit starting from your compressor until controlling the single actuator, the actuator will not move. Okay, so that is what we need to understand. So there's just a short intro. Okay, we'll go into the lecture note. Okay, so pneumatic circuit. Okay, so kita baca sikit. A pneumatic circuit is formed by various pneumatic components such as cylinders, directional control valve, flow control valve, pressure regulators, signal processing elements such as central valve, two pressure valve, etc. Okay. Okay, a pneumatic circuit. Kalau you tengok pneumatic circuit ataupun litar pneumatic, it is consists of various component. Dia bukannya ada satu cylinder sahaja. So you have a directional control valve. Apa function directional control valve? What's the function of directional control valve? Anyone? Kita
Directional control was to allow air to flow in either one direction.
okay, so directional control valve in general is to control the direction of your compressor. So nama dia pun directional kan. So it will direct. Okay, so macam director lah. You cakap, oh you pergi sini, you pergi sini. So similar, directional control valve, you can know from the name. Okay, so it control the direction of the flow. Flow control valve is controlling the amount of compressor. Berapa banyak compressor air is allowed. Because not all the place requires high pressure. So nanti kita akan tengok lah. So if you use push button, maybe it will only requires 1 bar. Tapi kalau nak control piston, maybe it requires 5 to 6 bars. Macam tu. So your whole flow control valve will have some mechanism inside to control the amount. amount of compressed air allowed. Then pressure regulators. So you are regulating the pressure. Regulator maksudnya, so let's say from your main compressor, you are receiving that 10 bar. For that particular component, it only requires 5 bar. So dia akan turunkan the pressure. Okay, so signal processing element. Okay, so I think you are familiar with shuttle valve and two pressure valve, or gate dengan end gate. So I think mostly tengah present sekarang. Your signal processing element, it will process signal yang you bagi. Okay, so whether it only requires one push button ataupun perlukan dua-dua push button. So your signal processing element will control. Okay, so when you combine all this, you boleh form a pneumatic circuit. Okay, tak kisahlah. So it's a single actuator cylinder ataupun double ataupun multiple actuator cylinder. Okay. So pneumatic circuit have the following function to control the entry and exit of compressed air in the linear rotary actuators. So dia nak yang penting adalah untuk kawal. Okay. So to control the compressor at the entry or exit point. Okay. So especially in controlling the actuators. Okay. So the second function, to use one valve to control another valve. Okay, kita dah tengok indirect method. So you use one valve, you bagi input as a pneumatic input, dia control another valve. Boleh juga. Okay, so you require a pneumatic circuit to do that, and to control actuators or any other pneumatic device. So the main thing is to control the actuators lah, the final cylinder ataupun motor, or any other pneumatic device, pneumatic timer ke. So anything can be controlled. So you require a circuit. Boleh tengok. So this is the structure, the circuit diagram structure for pneumatic system. This selalunya akan bermula dari bawah until ke atas. Okay, so easier to understand. Okay, so it will start with compressor. Okay, so compressor selalunya kita akan letak. Actually, you have the input arrow yang masuk kan. So if you don't want to use this kind of compressor, you letak arrow yang masuk dalam. Okay, so yang ni adalah exhaust. Okay, so then you go to FRL unit. Okay, so this is actually the complete system lah. So start from compressor, then pergi ke FRL. Apa tu FRL? Anyone? So remember?
Filter, regulator, lubricator.
Okay. So ada filter, regulator dengan lubricator. Boleh tengok balik lah chapter 2. Okay, so we have FRL chapter 1 and chapter 2 lah. Okay, so FRL unit is actually to prepare your compressor sebelum dia masuk ke system. So system not necessarily must be the same. Sebab tu subjek ni susah nak tipu. So kalau you lukis sama macam kawan, that means you memang tipu lah. Because this is a design problem. Okay, so design problem kita selalunya tak akan ada the same thing. Okay, so you can design. Okay, you can design according to your own creativity. Okay, selalunya dia start dengan supply element, then you have a input, okay, your push button or roller, then you have a processing element, signal processing tadi, then you have a control element where you will control. Okay, so you have a directional control valve. Then at the end, ujung tu adalah power element. Okay, so yesterday also I mentioned in the lab, please avoid letak vertical. Okay, so kalau you dalam design nanti dalam exam, you letak vertical, I will minus mark. Okay, so it doesn't matter. In internet, we have a lot of source. So kita ada banyak source yang you refer. So maybe dalam source tu dia letak vertical. But this is not a good practice. Dekat industry dia letak. So it's easier to interpret the circuit kalau you letak horizontal instead of vertical. Vertical, macam ni you tengok, oh the arrow is like this. So you know the flow is going from this side to this side. Yang ni you kena macam rotate your head to check kan. So it's not convenient. So I always encourage a good design practice adalah untuk letak horizontal. Okay, so this is practically your circuit diagram. Okay, for a single actuator, tak kisahlah yang ni adalah double acting cylinder ataupun single acting cylinder. So single actuator circuit meaning you only have one actuator. Okay, so diagram structure for the allocation of device to signal flow testing. So the comparison of a pneumatic or hydraulic system. So pneumatic dengan hydraulic ni lebih kurang sama. I think mostly things are the same. Except nama dia sama. Macam directional control valve untuk pneumatic is not like the directional control valve for hydraulic. So dia dia tak sama sebab the fluid that we are using inside is not the same. Okay, pneumatic kita gunakan compressed air, hydraulic kita gunakan oil. So you cannot use a pneumatic direction control valve to control hydraulic. Dia tak boleh. Sebab yang ni minyak, yang ni dia udara. So it will never work. But the names will be lebih kurang the same lah. Okay, so you can see, so input element, you compare dengan, kita selalunya akan compare dengan electrical circuit. The pneumatic atau hydraulic circuit, we compare with electrical circuit or electronic circuit. So you boleh tengok dekat sini. Okay, so input elements, so for pneumatic kita selalu gunakan switch, push button, limit switch. Limit switch adalah your ruler lah. Okay, then you have a program module. So maybe you use a program to give input. Ataupun kita selalunya akan gunakan sensor. Okay, electrical, so you tengok, almost the same. Just like how we compare earlier with the pneumatic and hydraulic component, dia ada perbezaan. So electrical, dia ada perbezaan dia sendiri. Walaupun nama dia lebih kurang lah. For the input. So then we see the processing element or control element. Here we have a direction control valve, non-direction valve, pressure control valve. But in electrical, we have a contactor, a switch. Okay, ataupun we have like some mechanism lah. Okay, so when you tekan push button ni, dia akan connect. Then you have a relay. So we have relays, so we have electronic modules. So we have then for control pun we have other stuff, transistor, thyristors. So we are familiar with all these components lah. Okay, so all have similar meaning. Control the direction of the flow. There's any direction of the current. Okay. And then power component. Power component meaning your actuator. Okay, so here we have cylinder, motor, or other constructional unit. And here electrical, yang ni kita biasa, electrical motors, solenoid. Solenoid if you have any electromagnetic device to power electromagnetic solenoid or the relay lah. Okay. Then you have linear motors. So this is practically a comparison between pneumatic or hydraulic system with electrical or electronic system. So structure dia sama. Okay, so you need to have an input, you need to have a processing, control, and power. Okay, a classic example, fan. So fan, you tengok, you ada switch, you tekan switch, your motor berjalan. Tapi dalam tu dia ada all the circuit board with the processing and control element. Yang kita nampak input dengan power je. So behind, you have this. So similarly, pneumatic also the same. We will only see the input switch. Then this will be in your circuit is hidden a bit. Then you can see the cylinder or motor moving. Okay, process sequence description. So there are several methods to describe process sequence. The process sequence maksudnya you want to explain from starting until the end of the process. Okay, macam tadi kita tengok, so dia start dekat sini until it reach here. Okay. So process sequence description maksudnya you want to describe your process dari starting until the end. So kita ada few methods yang kita selalunya akan gunakan. A simple narrative, positional sketch, boolean, motion diagram, function diagram, displacement diagram, control chart, and function diagram. Okay, so ada dalam 8 lah, 8 method. So 8 method untuk describe. Okay, meaning you read or you see this, you already understand and you already can describe macam mana. Macam I think yesterday dalam lab pun you ada describe. So you actually you press the push button, then it will go to all gate or valve. Then you need to have either one input. Macam tu lah. So you actually you are trying to describe the process. So we will see one by one. Okay. So this is a simple narrative. The simple narrative dia you kena buat karangan lah dari awal sampai ke akhir. So you need to consider all the inputs, the circuit. Dan yang saya garis ni adalah input. Inputs of the sensing element lah. Dia macam push button. Okay, so you have a sensor 1, time delay, sensor 2, time delay, then you have a push button, stop button. Okay, so you can see how it is narrated. The push button is used to turn on the conveyor belt A. Okay, so dalam pneumatic, we always will have symbols ataupun representation lah. Like yesterday, cylinder A, cylinder B. Dalam lab. So cylinder A, cylinder B. So it's easier for you to refer. Okay, so jangan cakap conveyor belt. Tapi dekat sana ada 3 conveyor belt. So you also don't know which one. So put number or alphabet. Normally kita akan letak alphabet lah. A, B, C, D, E. Then bring the bottles. So this is the actual system lah. Dekat production. So you cakap, okay, so you bring the bottle to the filling line. So sensor 1 that is placed at the center of the conveyor A will stop the conveyor belt A upon detecting the bottle and open the valve for filling for 2 seconds. So you ada satu sensor 1. When sensor 1 is on, timer akan start 2 second. So like your distance rule. Okay, so your cylinder extend, kena dekat your distance rule, so it will start. It will start another process. Okay, similar. Okay, after the conveyor belt will be on again until dan dia macam boleh sikit. Maybe the conveyor belt will be on again until the bottle is sensed by sensor 2 at the end of the conveyor belt. So you ada satu lagi sensor at the ujung conveyor to detect the end position. Then suppose after dia sampai dekat sini, dia can start timer and it will start another process. So you explain from starting until the end. So this is a simple narrative yang selalunya akan keluar dalam exam. Okay, so I will give a chat picture. So I will try ask you to do a simple narrative. Or saya akan bagi macam ni, ask you to draw. Okay, so you need to know how to interpret. Okay, from simple narrative to your circuit ataupun dari circuit ke simple narrative. So kalau saya nak bagi you marker, saya akan bagi circuit, ask you to narrate. Boleh juga, 5 mark. 5 mark. Depends on the circuit lah. Kalau circuit tu complicated, you will get more marks. Okay, simple narrative. Kita boleh tengok how to start it. So first, you need to identify the inputs and output. So input macam situation earlier. So you have a push button, sensor 1, timer 1, contact, okay, 2 second timer, ataupun time delay. Then you have a sensor 2 and time delay again for 3 seconds. The output, you have the conveyor A and also piston. So you have the solenoid lah, dia tak cakap piston, tapi dia cakap solenoid. Okay, okay, ada. Okay, so dia cakap ada piston to push the bottle to B. So you ada conveyor A, then you ada conveyor B. Conveyor B is I think it's running. So dia bukan jenis yang start. So it's continuous. So you tak perlu masukkan. So you only have output of. So you use a circuit to control conveyor A and piston. So conveyor B no need to be controlled. So that's the first stage. The second stage, please simplify the narrative statement. You tulislah dulu macam ni. Okay, so push button, turn on the conveyor A, don't stop for 1 second. Yang ni kalau dia dah sampai lah. So after conveyor A on, and to stop the conveyor, energize solenoid, timer for 3 seconds. Kita timer tu times up, masa lepas 3 second, conveyor A on again, button turn off, we stop. So yang ni depends on your system. Okay, then you can have a positional sketch or layout. Macam I bagi tahu tadi, you lukis gambar ni. Okay. Selalunya kami minta you lukis lah. We will give you a positional sketch. You can imagine. Okay. You can imagine dekat sini. Tengok ada conveyor. Conveyor is passing the stuff. Dia sampai dekat sini. So dekat sini supposed to have a sensor untuk sensor ni detect cylinder 1A extend. And dia naik ke atas. Okay, so dekat sini supposed to have another sensor to detect whether got stuff. So if you have any box here, cylinder 2A push. 2A push. Then cylinder 2A retract, cylinder 1A retract. So you ada few from the picture you boleh imagine. So yang ni pun boleh juga. Walau maybe a simple one lah macam ni. So at least you boleh imagine. Okay, so this will be the circuit. This will be the circuit. So it won't be like cylinder 2A push dulu baru cylinder 1A. Dia tak boleh push unless you have anything here. Okay, so all the cylinders will have a function. So you're gonna understand. You need to understand what will be the function. Like cylinder 1A is to push the box from this side to this side. Cylinder 2A function is to push the box to the next conveyor. So you need to understand the sequence lah, how the thing works. Here the positional sketch shows the relation between the actuator and the machine fixture. The actuator are shown in the correct orientation. Yang ni dia selalunya lukis dalam 3D. So you can imagine. Okay, the positional sketch is not normally scaled and should not be too detailed. Bukan ikut skala, meaning it's not the actual size. So it's just a sketch. Nama pun sketch. The sketch is lakaran. Okay. So the diagram will be used in conjunction with the description of the machine operation and the diagram. Tadi the simple narrative, it will come along. Selalunya kita takkan bagi only this. We will give with simple narrative and also this. So baru you lukis your skill. So that you boleh relate. Takut you silap understand lah. Silap misinterpret. Okay, then we have a boolean. Okay, apa tu boolean? Anyone? Still ingat your digit?
Yeah, logic operation.
Logic operation. Like any example?
Like or and not those kind of things.
Selalunya dalam pneumatic, okay, that's correct. But the one is in the digit. Tapi dalam pneumatic and hydraulic, boolean means true or false. Okay, so true or false, and is based on the gates. Okay, so logic expression. The logic expression is like betul juga. So it's a or. Okay, if or, so it's true, then it will start. So dia ada few sequence lah. Okay. Tapi yang ni kita selalunya takkan gunakan unless the system is very complicated. Very complicated, then you can use the Boolean way. So normally for your syllabus kita takkan gunakan Boolean. Okay, but maybe if you go to degree or in the industry, you will learn all this lah Boolean. Way of controlling or describing the process sequence. Macam tadi, macam dekat sini, okay, PB turn on conveyor A. So dalam Boolean, PB equals to true, conveyor A true. Macam tu. So that is what we call as Boolean. Okay, then we move to motion diagram. So you boleh tengok dekat sini. So who can explain from this? Ya, dah bagi jawapan kan. So you can explain. But if you just see this, so you boleh tengok dia ada dua cylinder, cylinder A and cylinder B. Always remember that another tips, tapi it's not to be taken as a holy grail lah. Holy grail maksudnya macam tetap kan. Selalunya kita follow the alphabet sequence. A dulu baru B. So from there you boleh dapat lah gambaran. Okay, cylinder A extend dulu, baru cylinder B. Okay, so you have a system here with the two cylinder and you have a stack of box. Dia panggil magazine. Okay, magazine. Okay, magazine. So this is chute. Apa yang dia akan buat? You ada magazine. So this magazine is based on gravitational force. Dia satu keluar, dia akan automatically comes down. So apa yang cylinder A buat, dia akan push the box to the chute. Okay, once, so meaning dia push, dia kena dekat sini, dia akan stop ataupun cylinder ni dia ada maximum distance lah, dia boleh extend. So selalunya kita akan set so that it will push tepat dekat sini. Okay, so when it extend, it will push the box to the chute, then it will move back. Okay, dia tekan selepas push, dia dah sampai kotak ni sampai dekat sini, it won't like stay, it will go back first. Okay, then cylinder B, dia ada sensor dekat sini, dia akan detect ada part, then this one will extend. Ataupun it will extend based on you have another sensor dekat sini untuk check whether cylinder A is retracted back or not. Kalau cylinder A dah balik, baru yang ni akan start. It's something similar like in your circuit lah, yang dalam lab. So meaning the process will be A plus A minus B plus B minus. Okay, plus maksudnya extend, minus maksudnya retract. So you can have any sequence. Sebab tu I beritahu dalam lab semalam pun when you do the demo, so you need to know the sequence and make sure that your process ataupun circuit follow the sequence. Macam application ni, what will happen if your sequence jadi B plus, B minus, A plus, A minus? What will happen? So B plus, B minus, A plus, A minus. Apa akan jadi kalau gambar ni follow that sequence? Okay, so anyone can try? Yeah. What will happen if instead of A plus, A minus, B plus, B minus, kita start dulu B plus, B minus, A plus, A minus. Hari ni macam semua slow lah.
Punya cylinder retracted kan?
Yang mana?
All the cylinders will be retracted, not extracted.
Tapi dia B plus meaning is already extend, B minus retracted. So what will happen to this operation kalau cylinder A extend dan retract, baru cylinder A extend and retract? What will happen?
The magazine doesn't get pushed.
Kalau you tengok imagine, cylinder B akan start, dekat sini tak ada magazine, dia push the air, so nothing goes into the box, then go back, then cylinder A extend, dia push the box, so box akan ada dekat sini. Betul kan kalau ikut sequence tu? So the box will not be pushed into the packaging. So your system will not work as how it's supposed to work lah. So that's why the sequencing of the cylinder is very important. Okay, so we have another thing we call it as a motion diagram. Okay, so motion diagram is actually I akan tunjuk lah in the next slide. Okay, so two cylinders are used to transfer. Yang ni actually the system lah. You boleh baca dekat sini how the system work. Okay, but from the picture itself, you can understand how it's supposed to operate. Okay, so this is your motion diagram. Okay, so kalau you tengok dekat sini, we have input and output separated with the input in the upper side, and output in the bottom side. So you boleh tengok you ada motion diagram is something that you need to understand. But kita selalunya akan guna, especially in chapter 5. Okay, when you are dealing with multi actuator cylinder, ataupun circuit. Okay, so you tengok dekat sini. What is A plus? Anyone?
The retracted.
It's cylinder A. So A means the cylinder label. So dekat sini ada dua cylinder. Cylinder A and cylinder B. A plus means cylinder A extend. Dia keluar lah. Keluar. So A minus maksudnya ditarik balik. So retract. We call it as a retract or pull back. So cylinder B extend, the B plus, B minus is retract. Okay, so you are the operation of the cylinder dekat sini. Okay, so this is we consider as a output. Input ini adalah switch. Yang you letak dekat distance rule kan. So you cylinder A ada switch A0 dekat retracted position, A1 at the extended position. Okay, samalah B1 dengan B0. Sama juga untuk cylinder B. Okay, so what will happen? So only if cylinder B is in the retracted position, you tekan push button, cylinder A extend. So dia extend, A1 switch A1 ataupun sensor A1 on. So kalau sensor A1 on, B plus dia start. Cylinder B extend kena dekat B1, switch B1. So kalau B1 dah aktif, cylinder A retract, A0 on. Kalau A0 on, cylinder B retract. Cylinder B retract, B0 again. Until you, dia akan start balik lah di sequence. Dia macam satu kitaran. Yeah, and maybe it will wait until you press the push button. Kalau tak ada push button, dia akan continuous, the same sequence. Faham tak macam mana nak lukis ni? Any question so far?
Faham, tapi nak implement tu yang pening sikit.
Apa?
I think faham, tapi nak implement benda ni jadi pening.
Apalah, baru nak start. Of course, starting tu pening. So, tapi saya akan bagi tutorial lah nanti. So, you try. You try to do. Fahami?
Boleh terangkan balik tak yang BO A1, B1 dengan AO? Kurang
Okay.
faham tak tu?
Okay, so dekat sini ada dua bahagian. Satu yang bahagian atas. Yang bahagian bawah, dia ada dua bahagian lah. Bahagian atas dengan bahagian bawah. Okay, so bahagian bawah ni apa? So, you bagi tahu. Bahagian bawah ni apa?
Output, sir.
Output. Cylinder lah. So, kalau A plus, cylinder A extend. A minus, cylinder A tarik balik. Okay. Kalau B plus, cylinder B dia extend. B minus, dia tarik balik. Okay, so you understand yang ni? Understand. Okay, yang ni, yang atas ni, yang B0, A1, B1, A0, B0 semua ni, I check tengok kalau ada apa pun. Okay, so maybe I gunakan yang ni lah. Yang ni dia actually dan yang lain. So katakan ni, lah, I just try to explain from here. Table icon here. So, yang ini adalah condition. Condition untuk cylinder ni buat operation ni. So, yang ni dia operation kan. Extend dengan retract tu dia satu operation. Okay. Yang ni adalah condition. So you tengok arrow dia sequencing. So kalau you nak buat A0 extend, dia yang ni condition dia adalah B0 kena on. So kalau B0 on, then you tekan push button, silinder A akan extend. So kalau silinder A extend, dia akan kena dekat mana? Kalau your distance rule ada dua, selalunya kita akan ada dua position kan, dua switch. Satu B0 untuk check whether silinder tu dalam retractor position ke tak, dan A1 untuk check whether silinder tu extended, kan? Faham tak? So kalau silinder A extend, dia akan kena dekat switch mana? Kalau silinder A extend, dia akan kena dekat switch mana? Anyone? We try to draw lah. Okay. Okay, maybe I can take 5 look first, so I can explain in another 5 minutes. To continue at 8:53. Can we start?
Yes, sir.
Elaborate. Okay. So I will explain this again. Kalau you tengok motion diagram, so you have two sides. Yeah, I letak dekat sini. So one side is the upper side. The upper side is actually switch condition. Okay, you tengok dekat sini ada berapa switch? Anyone? Ada berapa switch?
Two.
Two.
Two untuk each cylinder. Okay, dekat sini switch ada 4. A0, A1, B0, B1. Kan? How many cylinders?
The cylinders.
Two. So cylinder A and also cylinder A and also cylinder B. So you have two cylinders, cylinder A and cylinder B, and you have 4 switches, A0, A1, B0, B1. So what is the function of switch A0? Fungsi switch A0.
To start the whole operation.
Yes? Can't hear you.
Oh, wait. A0, sir.
A0, A0.
Is it to retract the cylinder?
A0 is actually, yang ni dia macam satu sensor. So you just bayangkan yang ni sensor. Apa yang sensor akan buat?
A0 tu di-detect dari B1.
So apa yang A0 akan buat, dia akan check whether cylinder A dia dalam retractor position ataupun extended position. So, kalau dia extended position macam ni, A0 akan on, A1 akan on, A0 akan off. Faham tak? Okay, dalam condition cylinder macam ni, which one will be on? Faham tak? Is it too complicated? Yeah. Try to simulate this and see. Okay, so kalau you tengok, cylinder ini dia bergerak. So if the cylinder in this position, so which switch will be on?
A0, sir.
Okay, A0 akan on, A1
Off.
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 So at one time, dia dua-dua ni akan on ataupun off. Okay, so if this condition happens, A0 akan on, dia akan detect that the cylinder is in the retractor position and A1 is off because dia tak detect apa-apa dekat sini. Dia macam sensor. Okay. So let's say your cylinder extend after some time until dia jadi macam ni. So now which one akan on, which one akan off? This condition.
A1 on.
A1 with on.
A1 akan on, A0 akan off.
Off.
Dia akan off. Dia bukan dia takkan detect bahagian ni lah. Sebab dia punya sensing material ada kat depan je. Faham tak? Jadi kalau yang ni selalunya dia akan detect besi lah. So besi tu akan ada dekat depan. So dia akan check. So where is the besi? Kalau besi tu ada dekat dengan A1, dia akan A1 akan on lah. A0 akan off. So similar for this. Faham tak? So you understand how this thing work? Kalau you tak faham yang ni, you takkan understand this part. Okay. Sekarang, we go to this. Kalau silinder A0, you ada dua silinder, silinder A and also silinder B with 4 switches. Okay, so you akan ada dua operation. So silinder A plus maksudnya silinder A extend. Okay, dia sequence dia silinder A extend, dia dah sampai fully, baru silinder B extend. Dia sampai fully, then silinder A retract, dia dah balik ke sini, then baru silinder B retract. So kalau dia nak buat operation ni, silinder operation ni, how it going to happen? Dia kena ada satu input kan? So input tu dari mana? Anyone? Silent ni. Okay, if your cylinder want to do this operation, from where it will get the input?
Oh, it gets it from B0 first.
So dia akan dapat dari switches ni, kan? Okay. So if you want to achieve A plus, what is the condition?
B0.
B, kalau B sebab dia punya operation tu dia macam satu sequence, kemudian dah habis ni, dia B0 akan aktif balik. Sebab semua silinder dah retract, so B0 dengan A0 aktif. Okay, so untuk condition untuk A plus ataupun silinder A untuk extend, B0 kena on. So meaning silinder B dah balik ke posisi asal. Okay, A0 dia tak kisahlah sebab yang ni dia hanya condition dia B0. Kalau B0 off and you tekan push button, silinder A akan mula extend. Kalau silinder A extend, switch mana yang akan on?
A1.
A1. So, kalau A1 on, ini adalah condition untuk B+. So, kalau dia dah extend, kena dekat A1, yang ni akan on. Okay, so condition is met. Then cylinder B akan start to extend. Cylinder B ni dia akan tunggu sampai A1 jadi on. Kalau cylinder ni dia baru separuh jalan, so A1 tak aktif, cylinder B takkan jalan lagi. So condition for B plus, A1 must be on. So dia dah extend, kena dekat A1, A1 on, baru cylinder B akan extend, B plus. So cylinder B extend, which one akan on?
Sensor B1 on.
Sensor B1 akan on. Dia extend, dia sampai dekat sini, B1 akan on. So kalau B1 on, yang ni automatically akan aktif. A minus. So cylinder A akan retract balik. So balik ke belakang, ditarik balik. So kalau ditarik balik, sensor mana akan on? Kalau dia balik, A0 akan on. So A1 akan off. So kalau A0 on, cylinder B, your operation B minus akan berlaku. So cylinder B will retract back. Faham tak? Macam mana? So this is the switching condition. Yang ni dia macam condition untuk perkara ni berlaku. Cylinder operation. Dia macam sensor lah. Kalau switch ni on, baru cylinder akan buat the particular operation. So that is how your motion diagram works. Faham tak?
Faham, sir.
I hope you really understand lah, because benda ni you akan guna dalam chapter 5 nanti. Okay, so try to understand this. Okay. Then we have function diagram. The function diagram sama macam motion diagram, but this is more like a flowchart. Okay, so flowchart dia letak tadi dia atas dengan bawah, kan? Yang ni atas dengan bawah. Yang ni dia macam tepi. That's actually the same thing lah. So 1, 2, 3, 4 adalah operation. So function diagram dia clear sikit. Okay, clear sikit sebab easier to see. So dia akan start sequence 1, sequence 2, sequence 3, sequence 4, kemudian dia ulang balik. Okay, so ulang balik. So kalau sequence 1, the operation dia adalah A plus. Sequence 2, B plus. Sequence 3, A minus. Sequence 4, B minus. So input ada kat tengah-tengah. Benda yang sama macam tadi. Cuma dia letak dekat, dia more organized lah. So you boleh lukis macam ni ataupun lukis macam ni. Okay. So sama juga sequence 1 A plus, sequence 2 B plus. So yang ni adalah condition dia. Okay, faham yang ni? Dia similar
Faham,
macam
sir.
similar macam motion diagram lah. Okay. Okay. Then we have a displacement diagram. Displacement diagram also selalu akan keluar. Okay, so you need to understand. Okay, so yang ni saya pernah baca banyak, saya boleh baca. Okay. So dia ada dua jenis. One is step ataupun sequence lah. Okay, step displacement step diagram dengan displacement time diagram. Yang step ni kalau you tengok dia punya distance ni sama je. Dia ikut sequence. Okay, so 1A ni apa? 1A dengan 2A. 1A dengan 2A ni apa? Cylinder number. Okay, cylinder 1A, cylinder 2A. So maksudnya kalau you tengok step diagram ni, dia ada berapa step? Dia ada berapa step?
5 steps.
5 step. 1, 2, 3, 4, 5. 5 equals to 1. So meaning dia return balik. Okay. So at step 1, cylinder A extend. So kalau dia naik macam ni, so down and up ataupun advance and return. So cylinder A extend. So the cylinder B still in the retractor position. So cylinder A dah extend, dia sampai ke step 2. So yang ni maintain. Cylinder A maintain, cylinder B akan extend. Okay, step 3. Okay, selepas step 3, cylinder A retract, B maintain. Then yang ni dia maintain in the retractor position. Step 4, cylinder B ataupun 2A retract. Then dia start balik. Step diagram dengan time diagram ni, the only difference will be yang ni distance dia sama antara step. Okay, so you lukis the same thing lah. Just kita akan tengok dia yang mana yang naik, yang mana yang turun. So kalau dia naik macam ni, the meaning is extending. Yang ni maintain. Yang ni dia retract. Yang ni pun sama. Okay, so step diagram. So time diagram dia ada satu lagi. So time diagram kalau kita gunakan timer ataupun time delay bar. Okay, so we normally will have 2 second, 3 second. So step dia sama. 1, 2, 3, 4, 5. Step dia sama. Tapi cuma dekat sini kita letak timing. Katakan step 1 to step 2, 3 second. 3 second for it to maintain. Selalunya untuk maintain lah kita akan extension ni dia ikut your flow rate kan. Actually you nak control pun boleh. It depends lah, depends on what. So time from sequence 1 to sequence 2, let's say 5 second. Sequence 2 to sequence 3 4 second. Yang ni kalau dia dekat, meaning is shorter time. Maybe 1 second or 2 second. So time diagram, time displacement time diagram is more how to say, more informative lah compare dengan yang ni. Sebab dia ada satu lagi scale the timing. So let's say the full operation is 10 second. So you kena ada 10 garis lah dekat sini. Start dari kosong until 10. Then 5 equals to 1 maksudnya dia start balik. You understand this? Boleh faham? Any question so far?
Understand, sir.
No question, sir.
Okay, so this is a displacement step diagram with signal lines. So yang ni benda yang sama tadi motion diagram. I think motion diagram you dah understand. So step diagram pun you dah understand. Cuma dekat tengah-tengah ni dia letak the switch condition juga. Ni macam tak macam ni lah. So B0. So kalau you tengok dekat sini B0 dia at the starting. Kemudian sequence yang ni adalah sequence 1. Okay, selepas sequence 1 dah habis A+, so dia akan letak A1 dekat sini. So dia dua-dua gunakan A1. Okay, so yang garis yang start ni adalah your condition. A1, so B+, B1 aktif. Selepas B+ habis, B1 aktif. Then A minus start. Then A0 dekat sini. Then B minus. So B minus, then B0 aktif. Then dia start balik. Line putus-putus ni is actually starting back. Go back to the initial sequence. Okay, so understand yang ni? I think all these parts are very important. Kalau you tak faham tu, please tanya. If not, you will not understand the next chapter. Okay. Then we have another thing we call as a control chart. The control chart is actually representing the only the switching input. Switch lah. Dan tadi, okay, 1V is actually a valve 1. Okay, valve 1 untuk silinder 1A. Tadi kita ada dua silinder. So dia akan check the switching lah. Switching of your, so, kalau dia open meaning ada connection. Kalau close meaning no connection. So depends. Kalau your circuit gunakan 5 switch ataupun 5 valve, you boleh letak 5 chart macam ni. Okay, so these are the step 1, 2, 3, 4, 5. Ini adalah condition dia. You boleh letak close or open or 0 or 1. Boleh letak kosong dengan 1. Kosong means close, 1 means open. Okay, open means is actuated, meaning ada connection. Close means no connection. So depends lah, dekat mana dia ada connection, dia akan jadi 1. So depends on the sequence. So I know memang dia ada banyak. So you try to check again, one by one, try to understand lah. Kalau tadi ada 8 kan, descriptive. So this is the control chart. Okay, so function diagram. Function diagram is something that we will use always. Kalau dia ada dua-dua. Satu dekat atas ni, displacement diagram, step diagram dengan control chart. We'll letak dua-dua lah. So based on the sequence, Dia cakap, okay, untuk sequence ni, kalau silinder A nak extend, yang ni adalah valve 1. Valve 1 yang attach dengan silinder 1. Yang ni dia aktif. Ni aktif. So kalau dia off, dia akan recheck balik. So dia off. Yang ni untuk 2V adalah untuk control silinder 2A. So kalau you tengok, yang ni dia off. Kalau nak extend dia on, maintain dia on. Kalau retract, dia off. Switch lah. Okay, so it's practically a combination with displacement step diagram and also control chart. So dia adalah combination. Next, I think I covered the 8 descriptive mode. Okay, so ada soalan so far? Any question?
No, sir.
Oh, okay. Kalau ada question, you can just ask during the discussion juga. So I will try to answer lah. Okay. So summary of procedure to develop a pneumatic system. So kalau you nak develop a pneumatic system, you need to consider a lot of stuff lah. So actually banyak benda yang kita panggil as good design practice. Okay, good design practice meaning macam I ada tanya, I ada ajar you. Okay, so previously I got say also, so draw your symbols horizontally, not vertically. Kalau vertically, so it will confuse a lot of people. Okay, to understand. So better to draw vertical, horizontally. So all that are some of the procedure lah, that you need to take into consideration when you are designing a pneumatic circuit. Okay, so we go through a bit. To understand the problem by considering type and quantity of component based on process sequence, inputs and output. So you need to understand first apa yang you nak dari starting until the end. So based on that, you determine what are the type of component yang you perlukan. So do you need a direction control valve? Do you need a off switch, or valve, or you need a push button? You need a roller. Macam malam, I think some of the case you perlu gunakan idle roller. You tak boleh gunakan roller biasa. Because you only, kalau you gunakan roller biasa, it will trigger both ways. So you need to consider the type of valve and inputs that you want to use, type of output, whether you want to use a rotary or you want to use a linear cylinder. So depends lah, and also the quantity. Okay, not only the type, you perlu determine the quantity also. Berapa banyak cylinder you perlukan. So don't like simple operation, you want to use 10 cylinder. So which will increase the cost of your design. So company takkan accept lah. Dia akan cakap, what a lousy engineer. So don't know how to estimate. Cost so much budget. So it must be optimum. So kalau 2 cylinders are enough to solve the problem, use 2 cylinders. Don't overdo or overcommit. Sebab kalau you gunakan more cylinders, so you will requires more component. So requires more money. So if you use less, then you cannot really achieve what you need to achieve lah. So you kena maintain good numbers and also the type. So that's the first thing. Second, the number of process. So, okay, ini katalah. So, number of process. How many steps are there? So, tadi kita tengok sequence. Okay, so process 1, process 2, process 3. So, process 1 is input. So, process 2 is signal conditioning. Then direction. Then you want to start your actuator. So, you need to determine the number of process involved. Berapa banyak proses yang ada. Okay, so try to make a good engineer will always make the optimum number of process. Lebih tak kurang. So identify method to start the operation. Okay, so you need to identify. So, macam mana you nak start? Okay, so let's say the question is given. So you need to use a push button. So you need to start with push button. Jangan start with roller pula. Because when you are designing something, you need to remember you need to fulfill the customer's requirement. Kalau customer tu nak start dengan push button juga, so jangan you pergi pandai-pandai letak another sensor. Nanti you dah design, you kena buat modification pula. So which will waste your time. Okay, so identify the correct method to start the operation. And you also must have a method to stop the operation. So jangan macam you only need macam I think some of your friends pun semalam present. So your circuit is continuously running. Padahal customer wants it to only run one sequence. Selepas habis, they want to wait for another push button, baru dia start balik. So it follows. Here's the method to stop the operation. So draw the cylinders and direction control valve horizontally, wherever possible. So wherever possible ni tolong abaikan. So always draw horizontally. Sebab international standard, so memang all the countries they buat horizontally. So yang ni buang lah. And modify circuit. Okay, so draw the cylinder and direction control valve horizontally. Okay, so as I say, if you still draw vertically, I will minus mark. Smart. Don't draw. So practice drawing things horizontally and not in rotated. So cylinder selalunya akan bergerak dari kiri ke kanan. So when it extend, jangan buat terbalik. So then you cakap, oh, I dah buat horizontally tapi terbalik. So still minus mark. Okay, so draw horizontally and in the correct orientation. Okay, kalau cylinder extend dari left to right. So, jangan right to left. So it will be confusing.
So,
Practically, yeah?
I add something.
Yes.
Okay, so I was thinking about what you said earlier about like if you present a design to a company and then they're gonna sue you for like bad design. What if we designed a circuit that uses like 17 different relays? Is that bad?
17 different?
17 different relays or like pneumatic timers. Is that bad?
It depends. Depends on the requirement.
Let's say it's like something simple.
So if it requires, because your design is like your business proposal. So your customer is coming to you and asking you to come up with a solution. So you design the solution and you show them. If they are convinced, they will invest or they will buy. If not, they will say, "Oh, this is too many." So it's not like to say using this many sensors or actuators is good or bad. So it's all depends on the demand and agreement.
So
Right.
what you're saying is, if we can convince them that it works, we can just.
I think last year I gave some case study. I think they use more than 20 volt to solve that.
Oh, that's not good.
So it's possible. Because in company, in the production line, you have thousands of volt, one production line. So possible, no problem.
All right, so thank you.
Okay, so the next, the energy flow within the circuit moves from bottom to top. Okay, the energy flow. So meaning circuit you start dari bawah. So from down it goes to up. So start from the compressor until the actuator on top. Okay, so don't draw the opposite. Don't put your compressor on top and cylinder down. So it will be confusing and you will minus the mark. Okay. The energy source can be shown in simplified form. Okay, so energy source you boleh letak macam ni. But don't put too many of this. Okay, so I tengok some of your lab, all the place you put this. Okay, so it will the main idea of circuit, it must be neat. Dia kena kemas. Kalau tak kemas, you letak too many of this. So I saw some of you also, you put this one, then you tarik. That look more neater than having too many of this. So imagine your system has 1,000 valve and you put 1,000 of this. Then your customer tengok apa benda yang gantung-gantung ni kan. So in your design. So look not so okay. So you just put one, then you tarik. So padahal benda tu sama je. Okay, so you give input, it will go to all the place. Okay, so try to make neat as possible. Okay, show elements the initial position. It's not actually initial position lah. Meaning it's not. It's supposed to be normal. Sorry, I prefer. Okay, so show the elements in the circuit in the unactuated position. Yeah, unactuated position. So if initially the thing is actuated, macam tadi kan, like this. So if the cylinder is in the retractor position, A0 is active. So if in the beginning of the circuit, this thing is active, show like this. So kalau dia ada surface macam ni, so if your symbol as surface like this, meaning is connected. So sebab tu dia ada dekat bahagian kiri. If not, it will be in this condition. So if initially this thing is actuated, so show in like this. You kena lukis macam ni. Meaning your roller is touching a surface and it's on. So kalau roller tu on, so you show like this. Kalau roller itu not on, yang connection ni you sambung dekat kotak kanan and this thing tak ada. So maybe you have question, what is this thing? So this is actually the roller is on and is touching a surface. So draw pipeline straight without crossover wherever possible. Jangan macam you ada circuit, tiba-tiba line tu dia macam jump here, crossing. So crossing, when you have crossover, so try to avoid that because crossover at times will will people can misinterpret kalau ada crossover ni. People maybe misinterpret or maybe yang ni dia macam dia join. Dia join. Selalunya kalau ada connection, you akan ada satu macam bulat. It's like a titik lah. Titik yang besar. So to show that it is connected. So kalau tak ada titik tu, so it will show as if like no connection. Okay, so in order to avoid confusion, jangan ada crossover if possible. So try to arrange so that it will go at the sides until it reach the place. I think maybe in chapter 5 and when you are doing the tutorial, you will understand better. Yes, you understand. If you use solid lines for power lines and dash line for pilot or control lines. Okay, so kalau you tengok dekat fluid scene, you when there is a compressor entering, dia akan jadi a thick blue line. So itu yang dicakap lah solid line. Solid line maksudnya so there's a connection there. Tapi when you draw in your exam, you don't need to thicken the line lah to show. Sebab kita boleh understand. Okay, so if this push button is pressed, this side supposed to F. So you will understand. Okay. And dash line for pilot control. So kalau your valve is controlled by another input from another valve, kita akan gunakan pilot line. Then you kena gunakan dash line. Dia bukan a continuous line. So continuous line is actually a power line. Kita akan gunakan dash line for control. Okay, so any questions on this slide? Boleh follow? I think I memang going very slow.
Boleh share.
So type of pneumatic circuit. So basically, there are two types of circuit control in pneumatic and hydraulic system. Okay, so kita ada direct control and indirect control. Okay, so based on your understanding, apa itu direct control and apa itu indirect control? So before I explain lah. Salah pun tak apa. So try to talk. I think I memang prefer face to face. But I boleh tengok your face kan. We have a COVID situation. So we need to settle it online. So online ni a bit boring because I only looking at my screen. And so try to interact. I know you all like new generation, more with your mobile phones. Okay, but try to talk because in company, you will talk more. Actually. Akan ada, I think last time when I work in the industry, daily morning you will have meeting. I think if you work in Japanese company, daily morning akan ada meeting. Last time I work in German company, ada juga meeting morning. So they follow. So in the meeting, you cannot be quiet. Your manager akan tanya, your supervisor akan tanya, then you need to answer. So try to interact. Try to explain things. Salah pun tak apa. But at least you try.
So, do you think it's better to work in a Japanese company?
So Japanese company will be very active because they are very workaholic, so work oriented. So if me, I prefer a US company. The US companies, they normally balance things. They like in Intel. So you will have a gaming room. So when you are stressed, you can just go and play game there or watch TV, then come back. And you will, so they will balance things. So they will de-stress you. Okay, so it's more balanced. But in Japanese company, you can learn a lot. So it depends on your preference. So you want a very balanced environment, or you want to learn a lot of stuff, especially when you are just starting your engineering journey, the engineer. So it's good to go to a Japanese company because they will teach you the culture. Because they, Japan, right? Japan, they recovered from World War II and very fast, and they became a superpower again because of their culture. So they are very disciplined. They will follow strictly, lah, especially the time. We cannot like expect. We cannot tolerate if you are late 5 minutes. So you need to be there earlier. So benda-benda macam tu. So it's actually very good for you to start your engineering journey. So once you already learn a lot of stuff, then you can jump. You can jump to other company lah. So engineers always will jump company. Sebab not for the promotion side lah, because it's when you jump company you can demand, but normally I won't encourage jumping company too much. Then your CV will become very cacat, So people will be asking why you always jump. So you're coming to my company, you want to jump after 3 months, after 5 months. Don't. So at least if you join a company, work at least 2 to 3 years before you opt to another company. And you need to provide a very sound reason for them to accept. So if not, they will only become just off track a bit. I hope I answered your question lah. Okay, so type of pneumatic circuit. So you have direct control and indirect control. So what is direct control? Anyone?
Direct control is
That means we
like
are
push button.
involved.
We are involved. Indirect. We are not involved.
Automatic.
I think indirect is something like our lab, which means we only use one button to indirect the direction of flow to the other valve. For my opinion, right?
So I think you all got the picture, but I will explain again. Okay, so direct control meaning you press the push button, the push button output straight away go to your actuator. In between, you don't have other valve to determine what to do. So indirect is opposite of direct lah. So you press the push button, it go to all valve, then it will determine something, then only it will reach your actuator. So that is indirect. Okay, so direct is normally will be easier lah to understand compared to indirect, because indirect will have more stages in between. So I explain. Okay, so now we are just seeing as a single acting cylinder. So it's not so complicated. Okay, the simplest level of control for the single and double acting cylinder involves direct control system. Well, here direct, you push button, straight away control. You tekan push button, dia terus extend. In between tak ada apa-apa. So the cylinder is actuated directly via manually or mechanically actuated valve. Okay, so manually meaning macam push button ataupun hand lever ataupun foot pedal. So mechanically selalunya gunakan roller lah, roller valve ataupun idle roller. Okay, so without any intermediate switching. In between tak ada apa-apa valve untuk buat switching of additional direction control valve. Okay, so itulah. Boleh tengok dekat sini. So this is the direct control of single acting cylinder. Now you ada push button. Tekan push button, your cylinder is directly connect to your cylinder. So this is a single acting cylinder. Dia cuma ada satu input and F spring. So you tekan, dekat sini pun dia ada spring. You tekan, dia extend. You lepas, dia push, patah balik. Okay. Sorry ya, yang ni bukan saya punya slide. So normal is this side. Okay, so when push button is pressed, piston produce a forward motion, dia bergerak ke depan. So when push button release, you tekan dah. Because of this, dia akan patah balik. Then your cylinder will move back. The cylinder face is connected to the exhaust port. Thereby, piston retract due to spring applied from the another port. And the spring. Okay, so this is practically a direct control of single acting cylinder. Okay, so this will be the question. Soalan macam ni lah akan ditanya nanti. Okay, so we give a positional sketch and we give you a description or simple narrative. A single acting cylinder of 25 mm diameter, so diameter dia is to clamp. Component when a push button is pressed, as long as the push button is activated, the cylinder is to remain in the clamp position. If the push button is released, the clamp is. Then you have the clamping application. You letak some part inside, tekan satu kotak. You tekan push button, dia akan pergi clamp. Lagi you tekan push button tu, dia akan clamp. You lepas push button, it will retract back. So this circuit, all the circuit you can draw it with direct or indirect method. Macam ni, you boleh lukis as a direct, you boleh lukis as indirect juga untuk application ni. So this is a example. Okay. Apa 0Z dengan 0S ni? Anyone?
Yeah, input element.
Okay, so this is actually, so I always encourage my student to draw this first. Instead of lukis just benda ni, to draw this. So this is an emergency button. So if anything happens, so all the system will have this emergency button. So if anything happen to the system out of control, you just go and off the emergency. Lepas tu dia ada dua side push button. So kalau dia on and then only you left like power lah. So if anything happen, you just go and off your system. So before you draw your circuit dalam exam, so I encourage you to draw this 0Z and also 0S. So dia masuk ke sini, then it goes here. So you press the push button, the cylinder extend. You release, because of the spring dia akan patah balik, it will go back. Okay, so circuit is actually only here lah. So direct way of controlling, designing the circuit for the application tadi.
Wait, sir, can you explain how the 0S button works?
Okay, so this button is like an emergency stop button dalam system. Whatever system yang you ada dekat industry will have an emergency button. So all the system, to stop the system if anything goes wrong. So it's always good to have a safety button, right? So when you design, I always encourage you to draw these two at the beginning of the circuit. instead of hanya lukis yang ni. Macam I tengok ramai yang hanya lukis yang ni. Terus ke sistem kan. Terus ke sini. Pressure pot. So, when in the exam, so I encourage you to draw these two first. Yang ni takkan ubah lah. Just lukis yang ni before it enters to your circuit.
How does it stop?
Okay, so you see, you have two sides. So yang ni dia always ada connection kan. You tekan sebelah sini. So imagine you have two push button at this side. You have push button, you have push button. Dia bukan ada spring. Macam ni. Yang ni dia one side ada push button, dekat sini ada spring. Kalau you release, dia akan patah balik. Yang ni, dia akan remain at this side until you press this side. Kalau anything happen, you just tekan button ni, dia akan tukar ke position ni. So yang ni dia disconnected lah. So the position of the arrow. Okay, understand this?
Yes.
Okay, so indirect control of a single acting cylinder. So it is suitable for large single cylinder as well as cylinder operating at high speed. So boleh baca lah yang ni. Okay, so I think. Okay, so you ada. Okay, untuk single acting cylinder, we normally will use a 3/2 directional control valve. Okay, untuk control. Okay, for indirect control lah. Yang macam tadi. So yang ni dia direct. Yang ni indirect. Kalau indirect, we will not, for single acting cylinder, we normally will use 3/2 directional control valve. Tak kisahlah normally close or normally open. Okay, so tengok indirect way of controlling. So circuit yang sama, example tadi, tapi kita like how I say, you can use a direct method and also indirect method. Dua-dua pun betul. Cuma dekat sini you have additional another valve lah in between. So you gunakan indirect way because it has a better control of your pressure. So tengok, so signal pressure requires can be 1 to 1.5. Maksudnya dekat sini you tekan the push button. So hanya 1.5 bar maximum release here. Here release here. Then from here it will control, it will supply 4 to 6 bar depending on the cylinder. So dia macam ada some management of compressed air lah. Okay. So maybe here you will ask why I need to add another component. Maybe since this is a very simple circuit, you don't really see the significance lah. Perbezaan antara direct and also indirect. But if you have a more complex circuit, so you will appreciate this indirect method. Because it will give you some flexibilities to control your circuit. Okay, kalau tengok yang ni, you tekan this button, it will send a signal to 3/2 direction control valve. So kalau ada input dekat sini, dia akan ubah and your cylinder akan extend. Okay, so kalau you release, dia akan ubah balik ke sini because of the spring. Then it will no signal here. So yang ni pun dia akan ubah balik from here to here. Kalau you tengok dekat sini yang dia ada dekat sebelah kiri. It will change back to kanan, meaning no connection. Then your cylinder will retract back. So example yang sama macam tadi, malah clamping. Tapi yang ni gunakan indirect way. So you see, yang ni you lukis, then you have a push button. Okay, so push button, when you press, it will send a signal to valve 1B. Dia akan ubah and your cylinder akan expand. Dan balik itu, if you release this, it will change to this side because of the spring and no input. It will change back to the normal position of the spring and it will retract it. Okay, so that's the difference between direct and also indirect method. Okay, so any question?
Yes, sir. Can
Yeah.
I ask is the OZ at the bottom the air filter component?
So it can be from the air filter or FRL, so depends. So this is actually the preparation stage of your compressor. Okay, so any question? I am done with today's lecture. The remaining of the lecture I will give as a add puzzle video, then we will discuss on next week Wednesday. So if you have any questions so far, we have 10 minutes. You can ask. Earlier we saw on the single acting cylinder, direct and indirect control. So in the video, I will cover on the direct control of double acting cylinder, also indirect control. So just to give a glance of what will be in the video for the direct control, this actually will be the same like single acting cylinder. Similar, yeah. You have this, and you have a push button. The only difference will be they don't have spring, because you need to give input for both, for extension and also retraction. And when you press the push button, another difference will be on the valve. So you won't use for 3/2. You'll use 5/2. Yeah, because double acting cylinder cannot be controlled with 3/2. You need to use 5/2. So you need to use 5/2 or 4/2 or 4-port to position or 5-port to position. Okay, so it will control. When you press the push button, it will change and your cylinder will extend. When you release, it will change back and your cylinder will retract. Okay, and indirect control, they're similar. Okay, for push button, you can use 3/2. It's simple. But for controlling the valve that controls the cylinder, you need to use 5/2 or 4/2. So it's actually the same thing like earlier. Just the difference between direct and indirect, in between you will have another valve to control. Okay, so you see in the video that I will repeat also. Okay, so any question so far? Okay, so for time being, we will continue online until the further notice, okay, so depending on the situation. So those who close contact or positive of COVID, please take care of yourself. Please recover soon. Okay, so I will, from my side, I'll try to give all these recordings in my YouTube channel. Please subscribe and get your notification every time I upload video. And I also give an advisor, okay, so that we can have a fruitful discussion. I prefer you ask me questions, okay, because it's easier to answer directly rather than you not doing well in your exam. Right? Better to ask question now, especially during the discussion. I see our discussion is like very one way still. Okay, only the same people are asking questions. Try to change the culture. So it's uh, always good to make a mistake when you're a student, then making mistake when you are in the company. Sama macam you learn driving license lah. I don't know whether I got give this analogy or not before this. So waktu muda-muda you pergi ambil driving license, you don't feel awkward because all same age. Imagine 50 years old, you tak ambil lagi license, 50 years old, baru nak pergi masuk sekolah memandu. You will feel awkward. You are the only senior, the others all like belas-belas tahun. So similar lah. So better to learn now, ask question, learn, try to understand the topic. So it's always better to ask question lah. So I think maybe it's not the Asian culture to ask question. But try to change lah if you are considering working in a multinational company.
Wait, sir,
Multinational company dia, memang dia akan cakap banyak. Okay. Razim.
I had an idea. Can we make our own compressor?
Home compressor.
Can we compress our own air? Is what I'm saying.
It will be very expensive. Are you willing to bear the cost?
The cost can
I
be
am
more.
making a low cost, so why not? The engineers always do things. Our job is to solve problems. Okay, so any other questions? Further questions? Volunteer.
So I have a question about pneumatic, the circuit design that we did yesterday.
Okay.
Um,
In the lab?
yeah, in the lab. I'm still not sure how to get that delay going. The A plus B plus and B minus A minus. I still don't know how to get that.
Some of your friends already managed to get. You need to change to idle roller. Because when you troubleshoot the circuit, if you just use a normal roller, you'll have a signal conflict. Signal conflict meaning in the direction control valve, both sides you are getting pilot input at the same time. So your valve cannot determine which one to do. So dia akan buat bodoh lah. Kan, you bagi dua input, suruh dia decide. And you don't give intelligence. So dia akan buat bodoh lah, dia akan buat dua-dua. It's practically what will happen, both sides will receive the same pressure. So it cannot move. So you need to eliminate one signal. So you need to eliminate one and only maintain one. So to do this signal elimination process, try to use idle roller. So instead of introducing some other concept, okay, so I saw some they use cascading method, okay, which you learn in internet. Okay, so cascading method we will study in the next chapter. So it's good, but the main thing is you need to maintain the same structure as shown. Sebab dekat lab module already I bagi kan, you just need to isi tempat kosong. So don't change the whole thing. I allow you to change some of the components dalam tu. Components I benarkan tukar, but don't change the whole circuit. So kalau you send the whole circuit in a different form, so maka akan kurang lah. Walaupun you boleh solve, you are not fulfilling the requirement of the question. Okay, so Fakrul Azim, try to use idle roller instead of normal roller.
So basically experiment with more of the components.
What do you mean? I can.
It's because I'll try to play around with the controls later.
Yeah, maybe you can refer to your friends. Some they managed to get that. Okay, so I think if you use idle roller, you change a few of the rollers to idle roller, it will solve. Just make sure you're switching the sequence like I told you earlier. Yeah, in this part. So make sure the sequence of the conditions, switching conditions are according to what you want. Lah. Okay, so A plus, B minus, A minus. Okay, so if you you want B minus to retract first, make sure A0 is active. So A0 active, then only B1 active. Then the sequence will be changed. Okay, any other question? Okay, so if no questions, I think we will stop here. So we will meet next week. Sorry, tomorrow I still have lab for one more group. So please present and you need to submit your lab report tomorrow. Okay. I think your class rep already assigned 8 people. So please collect and send it to not the mechatronic system design lab. It's in the other lab. It's just along the corridor in the next wing, not the other wing. So the next building. So because the mechatronic system design lab is the last part of your building. So it's in the beside. You just go to
Basically,
the end.
from the pneumatics lab, take a left and then just in that corridor, right?
So along the corridor, you just take the next corridor.
Yeah, I saw your logo, but I was wondering and I was lost.
I don't know whether you all have any lab there, but it's written there computer and instrumentation lab. It's just very nearby to our MSD lab. So just go and search, or you can just contact Wan Usna. You will be in that lab. Please submit by tomorrow 5 p.m. I think she already prepared a box there. Just put
Oh,
that.
wait, so one last thing. Is Juan now also the head of the robotics department?
Robotics, I don't think so.
Oh, yes.
Okay, so next week we will have quiz. Okay, quiz 1. We're covering the first 4 to 5 chapters. If I manage to cover, so we will do next week. So quiz 1. So it will be like my normal quiz, the game version. So we'll have 20 questions, and then you need to like play the game to score. Okay, so we'll have next week. Then in another 3 weeks, we'll have test 1. Okay, so before that, I will give some tutorials for you to try. So I think most of the tutorial for pneumatic, you can try at home. Okay, because you need to develop a circuit. Some will be the theory question. Then during the tutorial session, we will discuss some of the questions. Okay. I think if you have a further question, you can refer back to the teaching plan in the Google Classroom. We will follow that. Okay, so thank you so much. Okay, we will meet